I mentioned that y equals 10 to the x is particularly important. If you use a equals 10, then log to the base 10 of x are called common logarithms. You've all been exposed to common logarithms, right? Common logarithms are nice for the following reason. Log to the base 10 of 10 is, it's asking the question, what do you raise 10 to get 10? The answer is 1. So log to the base 10 of 10 is 1. Log to the base 10 of 100, or 10 squared, is 2. Log to the base 10 of 10 cubed is 3. And so log to the base 10 works well with our decimal representation. If you have a number whose log lies in the range between 1 and 2, it represents the log of the number which lies between 10 and 100. It's a 2-digit value, basically. If you have a number which lies between 2 and 3, it lies between 100 and 1,000. As a matter of fact, this is 10 to the 4th equals 4, obviously. So, if I look at a number like 343, I could write 343 as 3.43 times 10 squared. And then write log to the base 10 of 343. It's log to the base 10 of 3.43 times 10 squared. Which is, since this is a log of a product, it's given as the sum of the logs. So the sum of the logs are log to the base 10 of 3.43 plus log to the base 10 of 10 squared. Log to the base 10 of 10 squared is just 2. So I can write this as 2 plus log to the base 10 of 3.43. And this is a number between 0 and 1, because this number is bigger than 1, which is log to the base 10 of 1 is 0, and less than 10, log to the base 10 of is 1. So this number is greater than 0 and less than 1. Let me test this to see how far back your training goes. Do you remember what this number is called? Anybody know? Okay. Have you heard this term? It's a characteristic. This is the characteristic, and this is the mantissa. Have you heard those two terms before? Okay, so your training doesn't go back quite that far. Right? This is a characteristic, and this is the mantissa. And so what people used to do is create tables for the mantissa, right? Look at what is the log of 3.43, for example. It's going to be a number between 0 and 1. Notice, if you know this, then that tells you what the log of 343 is. It's 2 plus whatever that table says is the log of 3.43, right? So, what about the log of 3,430? Then you take 3,430 and write it as 3.43 times 10 cubed, right? And the log of 3,430 is 3 plus log to the base 10 of 3.43. And so each time you add 1, you're just multiplying by a factor of 10. So one of the beauties, back before calculators became ubiquitous, one of the beauties was you could create this table of the mantissa over there. Then you could write down, you could compute the logs to the base 10 of any number, whether it's 343, whether it's 34.3, whether it's 3.43, whether it's 3,430, for example. You could calculate this using that table. And the fact that the number of digits to the right of the decimal point, if you place this in the position, tells you the corresponding power of 10.
Which one's the mantissa?
This is the mantissa. And its advantage is that it's usable for whether you're talking about 3.43, 34.3, 343, 3,430. You use the same mantissa, and the only thing that changes is the characteristic. And that's why log to the base 10 became important. And like the slide rule, it disappeared with the advent of calculators.